When do you think the first human will step foot on Mars?
I think it's a good chance in the 2030s that we will be on Mars. In fact, there's no physics reason why we can't do it.
The Soviets were pioneers in space exploration, making several groundbreaking discoveries.
Today, a new moon is in the sky, a 23-inch metal sphere placed in orbit by a Russian rocket.
Great success in space when the Russians pushed a man across the threshold.
2, 1, 0.
However, what many don't know is that they also had secret missions to Mars, details of which were never revealed in public. What if the Soviet Union's Mars missions in the 1970s discovered something so groundbreaking, so earth-shattering, that even NASA felt compelled to investigate decades later? In the 1960s, a new kind of competition emerged between the United States and the Soviet Union. This wasn't just any rivalry.
Time for this nation to take a clearly leading role in space achievement.
This was the space race. Both nations were striving to conquer the final frontier, and the whole world was watching. Most of us are familiar with the American narrative. Who could forget Neil Armstrong's iconic words as he stepped onto the moon?
It's one small step for man, one giant leap for mankind.
Or the stunning images beamed back from the Hubble telescope. NASA was making headlines, capturing the world's imagination, and planting the stars and stripes on lunar soil. But while the world's eyes were fixed on NASA's every move, something extraordinary was happening behind the Iron Curtain. The Soviets were quietly making groundbreaking discoveries of their own, from launching the first artificial satellite, Sputnik, to sending the first human, Yuri Gagarin, into space. These were no small feats. One such enigmatic chapter involves the Soviet Union's first ever mission to Mars, launched in the early 1970s. This mission has been shrouded in mystery for decades. While the world was focused on lunar landings and space shuttles, the Soviets were aiming for the Red Planet. But what exactly were they looking for? And why has so much of this mission been kept from the public eye? The Soviet Union's Mars program was an ambitious series of uncrewed missions aimed at exploring the red planet Mars. Conducted between 1960 and 1973, these missions utilized a variety of spacecraft, including landers, orbiters, and flyby probes. The initial attempt in 1969 was a setback, plagued by design flaws and technical issues. However, the program gained momentum with the launch of Mars 2 and Mars 3 twin spacecraft. Mars 2 was launched on May 19, 1971, while Mars 3 took off on May 28, 1971, engineered to traverse the vast 200 million kilometer distance between Earth and Mars. These spacecraft were equipped with state-of-the-art technology. They featured spherical landing capsules, conical braking shields, retro rockets, and parachute systems, with an overall weight of 4,650 kilograms. These specifications bear striking similarities to modern-day space capsules. One groundbreaking innovation introduced by the Soviets was the Prop-M rover, a pioneering robotic exploration device. Weighing around 5 kilograms and shaped like a square, the rover was designed to simulate the observational tasks an astronaut would perform. It moved across the Martian surface using specialized skis that allowed for a hopping motion. Equipped with advanced detection systems, the rover could autonomously navigate and avoid obstacles like boulders and ditches. Remarkably, this autonomous functionality was achieved as early as 1971. However, the rover was tethered to the landing capsule by a 15-meter-long cable. The Prop-M rover provided invaluable data about the Martian soil, including its density, texture, and strength. Unfortunately, its operational lifespan was cut short, lasting only about 20 seconds due to technical malfunctions. Mars 2 suffered a similar fate, crashing on Mars due to system failures. In contrast, Mars 3 achieved a significant milestone by becoming the first spacecraft to successfully soft land on Mars, etching its name in the annals of space exploration history. The landing system was a marvel of engineering, involving a multi-stage process designed for the unique challenges of the Martian atmosphere. Initially, A specially designed parachute would deploy to slow down the descent. Following this, a set of retro rockets would activate to ensure a soft landing on the Martian surface. While the primary motivation behind the USSR's Martian expeditions may have been to outperform the United States in the space race, there was also a more enigmatic objective: the search for extraterrestrial life on Mars. The rovers on these missions were not merely designed to analyze soil and atmospheric conditions. They were also equipped to search for signs of biological life forms. Mars 3 even achieved a groundbreaking feat by transmitting the first ever live image from the Martian surface. Although the image was inconclusive, showing only a gray background, it was a significant milestone that filled the Soviet Union with pride. But the mission took an unexpected turn when Mars 3 suddenly went silent just 15 seconds into its data transmission back to Earth. The cause of this abrupt loss of communication remains a subject of speculation and debate. Some theories suggest that a Martian dust storm may have been responsible, while others propose more sensational explanations, such as interference by Martian entities, essentially suggesting that aliens could have sabotaged the mission. The loss of communication had severe implications for the mission's objectives. The Prop-M rover, which was tethered to Mars 3, was designed to be operated by a specialized arm on the spacecraft. Its movements were restricted to the field of view of the cameras installed on Mars 3, and it was programmed to stop every 5 feet to take measurements. Unfortunately, due to the sudden loss of communication, the rover never got the chance to explore the Martian surface extensively. Interestingly, the existence of the Prop-M rovers was kept a closely guarded secret by the Soviet Union. They were not mentioned in official reports and remained classified information for over 2 decades. This secrecy adds another layer of intrigue to the already mysterious circumstances surrounding the Mars 3 mission. It wasn't until the 1990s that the world learned about the Soviet Union's clandestine deployment of small rovers on Mars, a revelation that added another layer of intrigue to the already majestic space race. Documents later disclosed that not just Mars 2 and Mars 3, but also Mars 6 and Mars 7 missions were launched and carried small robotic explorers. This revelation led many to ponder what else might have been concealed by the Soviets. By the early 2000s, advancements in space technology had rekindled American interest in Mars exploration. In 2005, NASA launched the Mars Reconnaissance Orbiter equipped with cutting-edge instruments, including a high-resolution camera capable of capturing minute details on the Martian surface. One of MRO's objectives was to locate the Mars 3 spacecraft that had landed in 1971. Utilizing data and images from Mars 3, American scientists embarked on an exhaustive search for the lost spacecraft. Despite the passage of decades and the possibility that the debris could have been buried or swept away by Martian storms, the MRO captured images showing what appeared to be wreckage, including a recognizable parachute. Nearby, a circular metal object was speculated to be the Mars 3 lander, along with a dark area suspected to be the landing site. Although these findings couldn't explain why Mars 3 had failed, they validated the Soviet mission's authenticity. Interestingly, this led not to renewed rivalry, but to collaboration, culminating in the International Space Station. The Martian landscape has long captivated astronomers and scientists due to its unique features and phenomena, one of the most striking of which is the occurrence of massive dust storms. These storms are not mere meteorological events, but epic occurrences that can engulf the entire planet and last for weeks. During such periods, Mars transforms from a seemingly lifeless red celestial body into a turbulent, amber-hued sphere. The planet's topography and atmospheric conditions are conducive to the formation of these storms, and the barren landscape amplifies their impact. According to classified files, seconds before the successful Mars 3 rover went silent, the rover sent a signal. The last image transmitted back to Earth was a nondescript gray background. This led many experts in the Soviet Union to hypothesize that one such colossal dust storm might have been responsible for the mission's premature end. The theory seems plausible when one considers the volatile and unpredictable nature of Martian weather, which could easily disrupt even the most well-planned missions. Despite meticulous planning, state-of-the-art technology, and rigorous training, there are no guarantees of success. Take, for example, the Mars 2 mission. It was equipped with all the necessary technology for a successful landing. But a last minute failure in the rocket systems led to a catastrophic crash. The Apollo missions also had their share of near disasters. During the Apollo 11 mission, the lunar module experienced difficulties during its descent to the moon's surface. If it weren't for Neil Armstrong's quick thinking and manual override of the control systems, the mission could have ended in tragedy. Such incidents underscore the inherent dangers and uncertainties that come with venturing into the unknown realms of space. The Mars 2 and Mars 3 missions were groundbreaking endeavors, and each of these spacecraft was a dual-component system, comprising an orbiter and a landing module, designed to function in tandem for comprehensive exploration of the Red Planet. The scientific payload on these missions was nothing short of impressive. They were equipped with an array of sophisticated instruments, including but not limited to ultraviolet spectrometers, infrared radiometers, photo cameras, and magnetometers. These instruments were meticulously selected to serve a broad spectrum of research goals. The ultraviolet spectrometers, for instance, were tasked with analyzing the composition of the Martian atmosphere and soil. These analyses were crucial for understanding the planet's geological history and assessing its potential for hosting life, either past or present. In addition to the spectrometers, the spacecraft also carried infrared radiometers that were designed to measure atmospheric pressure and water vapor levels. This data would provide invaluable insights into the Martian climate, aiding in the understanding of weather patterns and seasonal changes on the planet. The magnetometers, on the other hand, were focused on gauging the intensity and direction of Mars' magnetic field. Understanding the magnetic field is essential for studying the planet's core structure and its geological activity over time. The dual-component design of an orbiter and a lander allowed for a multifaceted approach to Martian exploration. The array of scientific instruments on board was carefully curated to provide a comprehensive dataset that could help answer fundamental questions about Martian geology, climate, and the potential for extraterrestrial life. After the launch of the Mars 3 mission, the Soviet Union redoubled its efforts to ensure the success of future space endeavors. Regardless of the USSR's hidden secrets, the Soviet Union has been a frontier of space exploration because of its huge financial backing, and one of their most iconic achievements was sending the first woman, Valentina Tereshkova, into space in 1963 aboard Vostok 6. But their ambition didn't stop there. They were the pioneers, launching the world's first artificial satellite, Sputnik. This 183-pound sphere sent shockwaves around the world, literally kick-starting the space race. They even sent the first animal, Laika, into Earth's orbit, although sadly she did not return. During the Cold War, the Soviet Union was engaged in a fierce rivalry with the United States while the world held its breath, anticipating a potential nuclear conflict. Soviet scientists were busy charting a different kind of trajectory, one that led to the stars and planets. One of the most audacious of these endeavors was the Venera program, aimed at exploring the planet Venus. While NASA was focusing its $25.4 billion budget primarily on Moon and Mars missions, the Soviets took a gamble on Venus. This amount is approximately $257 billion when adjusted for inflation to 2020. The spending peaked in 1966, 3 years before the Apollo 11 mission landed on the Moon, and the Soviets were headed towards interplanetary conquering. The Venera program, initiated by the Soviet Union, was a groundbreaking series of missions aimed at unraveling the mysteries of Venus, a planet notorious for its extreme and inhospitable conditions. Venus's atmosphere is a cauldron of high pressure, approximately 92 times that of Earth, and is composed of toxic gases like carbon dioxide and sulfur. This dense atmosphere acts as a heat trap, making Venus the hottest planet in our solar system, with surface temperatures averaging around 400 degrees Celsius. In contrast, Mercury, the planet closest to the Sun, experiences temperature fluctuations, cooling down to 173 degrees Celsius at night due to its thin atmosphere. While NASA chose to focus its efforts on lunar and Jupiter missions, The Soviet Union took the audacious step of exploring Venus. The early stages of the Venera program were fraught with challenges. The first two missions in the early 1960s failed to achieve their objectives. Venera 3, launched in 1965, crash-landed on Venus without transmitting any data back to Earth. However, the program gained momentum with the success of Venera 4 in 1967. This mission not only successfully landed on Venus, but also transmitted valuable data for approximately 90 minutes before succumbing to the planet's extreme conditions. It provided groundbreaking insights, revealing that Venus's atmosphere lacked oxygen and water and was primarily composed of carbon dioxide. Additionally, it confirmed the absence of a magnetic field on Venus. Provoked by the success of Venera 4, the Soviet Union launched 12 more missions, each more advanced than the last. Venera 5 and 6, launched in January 1969, just 5 days apart, were equipped with enhanced technology to withstand greater atmospheric pressure and collect more accurate data. Venera 8 managed to capture photographic images of Venus despite the planet's harsh climate. The pinnacle of the program was the Venera 9 to 12 missions, launched between 1975 and 1978. These spacecraft weighed up to 11,000 pounds each and were equipped with landers that could capture high-resolution images. Nonetheless, these images and other data were kept classified by the Soviet Union until they were eventually leaked by a Soviet astronaut. After the Venera missions and its suspiciously disappeared footage, the Soviet Union redoubled its efforts to ensure the success of future space trials. For instance, Soviet missions to Venus, particularly Venera 13 in 1982, gathered extensive data, including high-quality photos and evidence of organic molecules, fueling speculation about extraterrestrial life. Yet, not all this information has been disclosed, leaving us to ponder what other cosmic secrets might be kept under wraps. The Soviets had not only been successful in reaching Venus, but had also conducted other special missions, such as the Luna program aimed at exploring the Moon. The Luna 2 mission was the first human-made object to reach the Moon, and Luna 16 returned soil samples to Earth, another first achievement in the history of space exploration. However, the Soviet space program was not without its share of tragedies. The Soyuz 11 mission resulted in the deaths of 3 cosmonauts due to cabin depressurization, and several other missions were plagued by failures and near misses. Despite these setbacks, the Soviet Union's space program was a testament to human ingenuity and the relentless pursuit of knowledge, even in the face of geopolitical tensions and immense technical challenges. In 2020, a Russian cosmonaut named Ivan Wanger shared his experience while recording the Aurora Australis from the ISS. Wanger's onboard cameras captured footage of objects resembling UFOs. The video, which gained significant attention online, was submitted to ISS authorities, but has yet to receive official comment. This adds to existing questions about what space agencies might be withholding from the public. But here's where the story takes a turn for the mysterious. This footage, as groundbreaking as it was, never saw the light of day. It was shared only among a select group of officials and scientists, kept under wraps as if it were a matter of national security. No press releases, no public discussions, and certainly no explanations. The silence surrounding Ivan Wanger's UFO footage is deafening, and it raises questions that extend far beyond one isolated incident. These endeavors, despite their mysteries and challenges, have collectively enriched our understanding of space. They remind us that in the quest to explore the cosmos, the line between the known and unknown is often blurred, and what's concealed today could be tomorrow's revelation.